Good day, everyone. Today, I'm discussing the three chapters of our reference textbook, which is the Victor Mechanics for Engineers 10th edition by Beer, Johnston, Mazarek, and also Cornwell. So the first part will be the kinematics of the particles. In dynamics, as definition, this dynamics is a part of mechanics that deals with the analysis of bodies in motion. Kasi before, yung statics is, ano man yun, there is no motion involved. So, now, these dynamics have two parts. The first one will be the kinematics, which treats only the geometric aspects of the motion, and the second one will be the kinetics, which actually the analysis or involving the analysis of forces causing the motion. So, rectilinear motion of a particle. Rectilinear motion from the word rectus and linear. Rectus, linear. So, rectus is a word for a straight. And then linear naman, dyan natin nakuha yung word na line. So that is why, kapag kasi sinasabing rectilinear motion, it is when a particle moves or moving along a straight line. So, position, velocity, and acceleration. Figure 11.1 illustrates the position. So, to define the position P, we have to choose our origin, O, here, 1. So, there is X here, the distance that traveled. So, the distance here. So, to discuss or to define this P here with a correct sign notation, since this P moves in the positive axis of our straight line, so this one has the positive sign. So this will be X is equal to positive 5, and also the X with an apostrophe here at figure 11.1b, so will be a negative 2. So which this position P with an apostrophe moves to negative 2 of our negative axis, x-axis. So here. So the correct or the X or the distance that has an correct sign, we can call that a position coordinate. So this position will actually have a unit of meter per meter when we talk about SI units, and for the US customary naman, we'll be having this feet. Velocity. So average velocity is the average rate of change of position or displacement with respect to time over an interval. So it represents here the change of x over the change of t. While this instantaneous velocity represents the velocity at a particular moment. So a specific rate of change of our displacement with respect to time at single point. So kaya it denotes here that V is equal to the delta x over delta t with the limit as delta t y approaches to 0. So units here will be meter per second squared for the SI. Then for the US customary naman then, we can use this feet per second squared. Average acceleration of a particle over the time interval delta t is defined as the quotient of the delta v and delta t. So here. And instantaneous acceleration naman then is the limit of our average acceleration as the time interval approaches to 0. So it denotes here A is equal to the delta v over delta t as t approaches to 0. Or we can rewrite that into dv over dt. So we can also denote that into, di ba? Kasi it's the rate of change man yan, yung v. Yung v is dx over dt, di ba? Kanina, dx over dt. So we can denote also, or we can write also that instantaneous acceleration into A is equal to d second derivative x over dt squared. So the first part here, is it accelerating or not? Well, makikita nyo ang car na may velocity from 30 km per hour down to 60 km per hour. So, well, it is accelerating. It is accelerating. Well, let us identify kung positive ba siya or negative. Well, makita nyo na from 30, tumaas yung velocity. So, it means it is positive. It has a positive acceleration. So, this one naman din, constant siya from 60 km per hour down to 60 km per hour pa din. So, constant siya. So, matatawag natin siyang positive acceleration. While here, so, ano to? Is it positive or negative? So, this one here is actually nag-accelerate pa rin siya. Pero, negative nga lang. Negative yung acceleration niya. It is because from 60 km per hour, yung kanyang velocity, it turned down or nag-re-reduce siya into 30 km per hour. So now, let us go to the example. The motion of particle is defined by the relation of x is equal to t to the fourth minus 10 to the t to the second plus 8t plus 12, where x and t are expressed in inches and seconds respectively. Determine the position, the velocity, and acceleration of the particle when t is equal to 1 seconds. So here, our given sometimes will be in terms of equation, kagaya nito. So, naka-equation siya yung given. So, our given, as sinabi ko kanina, x is equal to t to the fourth minus 10 t squared plus 8t plus 12. So, required is the position, so which we denote as x, the velocity as v, and the acceleration as denoted as a at time is equal to 1 second. So, now, solution. Since we have the equations, we are given with equations to solve the position to which denote as x, well, kailangan lang nating directly substitute the value of t, which is 1 second. So now, substituting that 1 seconds into our equation that we have, we'll be able to get or come up with 11 seconds. So yung position niya, or x, is equal to 11 inches. So 11 inches. So, solving for velocity, so we know that the velocity is just the derivative of our position per time. Since here, this one here is kailangan natin siyang i-derive. So, here, so for the derivative of this one here, di ba? So, you will still recall the derivative. So, 4t cubed, yung magiging derivative niya, minus 2 multiplied to 10, then t, kasi 2 minus 1 is magiging 1 lang, so t. So, 2 times 10 plus 8. Then, the derivative of our constant is equal to 0. Kaya magiging, ano na lang siya, magiging 4t cubed minus 20t plus 8. And then, since we are given with at the time, 1 second, so we have to substitute that in our equation na na-derive. So, which 4 times 1 to the cube minus 20 times 1 plus 8. So, it gives us a negative 8 inches per seconds. So, now to solve the acceleration, we know that acceleration is just the change of the velocity per change of time. So, the delta v over the delta t. So, as discussed kanina. So, since meron na tayong equation here for our velocity, the 4t squared cube minus 20t plus 8, so, i-derive pa natin yan with respect to time. So, magiging 4 times 3 t squared minus 20 na lang kasi magiging 0,2 siya. So, that gives us 12t squared minus 20. So, at 1 seconds, magiging, ang acceleration is magiging negative 8 seconds, negative 8 inches per second square pala. So, that is so. Therefore, yung position is equal to 11 inches. The velocity will be the 8 inches. And not just 8 inches here, but negative 8 inches per second. And the acceleration will be 8 inches per second square. So, dito, kulangan siya ng square. Well, now, we are done with the first part of our kinetics of the particle, which is the rectilinear motion. Let's proceed to the curvilinear motion of a particle. So, kanina, along with the straight line na siya. So, here, other than the straight line, so yung ating particle is actually moving in a curve. So, matatawag siyang curvilinear motion from the word itself, curvilinear. So, it is when a particle moves along a curve other than a straight line. So, here makikita nyo dito, the position P, actually, our textbook will be using P here, denoting P here, at a given time is defined by the position vector. Here, this is our position vector, this R1. Joining to the origin. So, joining to the origin here. So, of the coordinate system at the point P with an apostrophe. So, here, the change. So, velocity here is defined as the change of our position vector per change of time. So, that is naka-circular. So, velocity vector is tangential siya sa path ng ating particle. So, if this is the path of our particle, one here, so dapat yung velocity vector natin is tangential siya. So it has the magnitude of a v equal to the time derivative of length, the derivative of our length, the s here, of the arc described by the particle. Which v, masasabi natin that v is equal to the derivative of our length, ds, over the delta t or the dt, derivative. So in general, acceleration of a particle is not tangent to the path of the particle. Diba? Kasi yung ating velocity is tangential but the acceleration it's not. So here, this is the acceleration. It is not tangential of our particle, of the path of our particle. So it is defined by the relation as A is equal to the delta V over the delta T. So rectangular component of velocity and acceleration, and also meron ding position here. So ang makikita nyo dito, it is expressed into rectangular component here. So figure 18 or 11.18. So A and B. So now, so for the position vector, we will be having our xi, yj, this is yj, and also zk. So for the position vector. And also for the velocity vector naman din, which is equal to dr over dt, meron siyang xi dot, y dot j, and z dot k, so which is 11.27. And the acceleration will be dalawang dot, so double dot ng ating kasi that is the double derivative kasi yan. So it is the second derivative of our position vector. So, and also y with a double dot j, and z double dot k. So that is 11.28. A car is traveling along the circular curve radius 300 feet. At an instant shown, its angular rate of rotation is 0.4 rad per second, and which is increasing at the rate of 0.2 rad per second squared. So determine the magnitude of the velocity and acceleration of the car at this instant. So here, illustration of our problem is this one. So nandito daw yung car natin. So ito yung ating radius, 300 feet, and this is our theta. And our acceleration, this one, and our velocity, we are given also. So, sinabi ko na kanina yung given, 300 feet, yung theta dot is equal to 0.4 rad per second, and the rate, the increasing rate, the acceleration will be, the theta with the double dot is equal to 0.2 rad per second squared. So, required is the velocity and acceleration, and the magnitude rather of our velocity and acceleration. So, solution, since the circular radius are not changing, circular radius, so ang kaniyang velocity ng ating radius or is equal to r dot is equal to 0, which is ang ating velocity with respect to our theta is equal to r multiplied to theta dot. Since given naman tayo ng radius at saka ng ating velocity, so theta dot is equal to 0.4 rad per second. So multiplying that we'll be getting the v theta, which is equal to 120 feet per seconds. So solving for the magnitude velocity of the car, so we can use that Pythagorean theorem in this part. So remember that Pythagorean theorem, c squared is equal to a squared plus b squared. So in this part, our velocity or the magnitude velocity is we relate that into the radius and its theta. So that is why it is now given as v squared is equal to vr squared plus v theta squared. So since we have the 120 feet per second as value of our v theta and our vr, kasi hindi naman changing yung radius ng ating circles, so kaya't zero siya. So we'll be getting the 120 feet per seconds as our magnitude, the velocity magnitude. So continuation, by equation, A is equal to alpha r double dot minus r dot square to the raise of 2 plus the r with the double dot multiplied to the double dot theta plus 2r dot theta dot raised to 2. So this one is the radius, the second derivative man to siya. So in this case, r dot is equal to r with a double dot lang siya is equal to 0. So kaya't magiging 0 to siya, magiging 0 din tong isa nito. Kaya't yung matitira is this one na lang, r, and this r with a double dot. So these are 300 feet per second. We multiplied that. Yung radius 300 feet lang pala dito. It's not with seconds. So kaya't multiply to 0.4 rad per second plus 300 feet multiplied to our 0.2 rad per seconds, magiging ano siya, ito siya, magiging 0 na to siya. So we are left with this one here. As I've said kanina, yung negative 300 feet, hindi siya naka-second, sorry. Dito. So multiply mo to siya. Ito siya, combining this one, magiging negative 48.0 feet per second squared. Plus, 60.0 feet per second squared. So multiplying that one. So we'll be getting, since meron na tayong kanina, di ba, ER and VR. So combining that one, we'll be getting 76.84 feet per seconds. Therefore, our magnitude velocity is equal to 120 feet per seconds, and our acceleration will be 76.84 feet per second squared. So now let us talk about the kinetics of particles, the lecture 2, which is all about Newton's second law. Newton's second law of motion, so the summation of forces is equal to the mass times acceleration. So if the resultant force acting on the particle is not 0, so the particle will have an acceleration that is proportional to the magnitude of the resultants and in the direction of the resultant. Well, considering that, we'll have to express that into a Newtonian or inertial frame of reference, which is the other body, or one is not accelerating or one is not rotating. So this form of the equation is for a constant mass system. So now, for the linear momentum of a particle naman din, so diba, we know that the summation of forces is equal to mass times acceleration. So yung acceleration dito is i-change natin siya into the velocity yield or the derivative of the velocity yield. So that is 1 instead of a here, magiging dv with an arrowhead over dt. So which we know that diba, mass times acceleration is force, while mass times velocity, so the mass times yield of the velocity will be our linear momentum of our particles. So magiging a delta f, it's not delta f but summation f with an arrowhead is equal to the dl with an arrowhead over dt. So which is actually with respect to the linear momentum of our particle. So linear momentum conservation principle, so kung ang resultant force daw of a particle is hindi zero, is zero, so linear momentum daw sa particle remains constant in both magnitude and direction. So, equation of motion. So, here, expressing this out, di ba? And two equations of motions as an scalar equations. So, for the rectangular component, so we have the particle here, we have the position vector here. So, we have the accelerations, di ba? We have the accelerations that we are going to consider here as, so, yung ating acceleration na dito, so which meron siyang component between sa axis na x, y, and z. So, here. So, for the rectangular components here, so the delta of the forces, diba? Delta of the forces na nasa x-axis, y-axis, and z-axis is just equal to the mass multiplied to the acceleration with respect to the component ng ating x-axis, y-axis, and then z-axis, which a summation of fx or yung summation ng ating force at x-axis is just equal to the mass times accelerations with sa ng ating x-axis. And then for Fy naman then, for our y-axis, summation of our forces at y-axis is equal to the mass times acceleration at y-axis. Then the summation of our forces at z-axis is equal to mass times acceleration with respect to the z-axis. So here, we can also write this one as a is equal to x with the with a double dot. Kasi acceleration is the second derivative siya, diba? So we can also express that into ax is equal to x dot. Same goes with what happened here in our summation of forces with respect to x and y then. So system units of our force. So for the force, 1 Newton, this is for the SI. 1 Newton or is just equal to 1 kilogram multiplied to 1 meter per second square. So cancel. So it is just equal lang siya yung 1 Newton. So and for the US customary naman din is 1 pound mass is equal to 1 pound over 32.2 feet per second squared, or 1 slug, conversion ng slug to pound is just equal to 1 pound over 1 feet per second squared, or just equal to 1 pound second squared over feet. So free body diagrams and kinetic diagrams. Actually, this is very important when we talk about or when we actually solve problems. Kasi in this part, we will be able to analyze and be able to understand through illustration of that problem. So, for example here, so this is the body that we are considering. So first step that we have to do is to isolate the body. The second step is to identify or define its axis. Third step and fourth step until fifth step is that we applied forces. Kung ano yung forces nag-a-act sa ating isolated bodies, and then i-replace natin yung supports with forces, and then we also write the dimensions para mas define siya. So the next one will be able to write that or express that or illustrate that body or isolated body when it comes to kinetic diagram. So here, so since our axis here is x and y, so which our forces will be that we are considering in the kinetic diagram is at MA, y, and MEX. So now to be able to understand it more, so let us have our example. The two blocks shown are originally at rest, neglecting the masses of the pulleys and the effect of friction of the pulleys between block A, this is block A, and the horizontal space. This is the horizontal space. So determine A, the acceleration of each block. Second will be the tension of the cable, the tension of our cable here. So the tension of our cable. So now the given, we have the given. So the given natin is yung mass ng ating block A is 30 kg and mass ng ating block B is 25 kg. Yung required acceleration ng ating both ng ating block A and block B. and also the tension of that cable, which is the T. So, kailangan nating i-identify at saka express ng ating diagram para mas klaro siya. So, pipili tayo ng axis niya. So, papunta dito to the left here is our positive and pababa is our negative. So, this one is the length. So, kahit na gaano mag-move yung ating blocks, yung block A or block B, this part here is equal pa rin yan at constant pa rin yan. 'Di ba? Constant pa rin yan. Hindi yan nagbabago. So, solution. So, for the FBD, we have to, yes, isolate the body of the interest. So, yung body of interest natin is yung mga blocks A and blocks B. So, draw the axis system. So, yung axis system natin, ito yung axis system natin, yung proper niya. So, we consider positive X papunta doon and positive Y naman dito. So, add in applied forces dito kung ano yung force na nag-a-act ng ating bodies. Then, we have to draw the appropriate dimensions. Well, for block A, so yung forces na nag-a-act, well, yung weight niya, which we know that weight is just equal to mass A. Kasi sa block A to siya times the gravity. Then, the normal force here, NA, na nag-a-act ng ating body. And also, this is meron tayong cable here. So, meron siyang tension. So, papunta doon. So, for the block B naman din, we have this ilang tension siya. So, may mga tension. Well, dito is 2T. And then, other tension 1 here, ito is 1. So, which is upward. Then, our block B, so, yung weight niya is mass B multiplied to the gravity. So, for the KD or kinetic diagram naman din, we have to isolate the body of interest and draw the mass times acceleration of the particle, which is what we did here. So, here is our, di ba, as I've said kanina, we already defined the axis of our, or the axis system of our systems, or the isolated bodies. So, here, positive is A, may positive X dito. So, which mass times mass of our block A multiplied to the acceleration with respect to our X-axis. And for the block B naman din, pababa. So, which is mass times A, B, Y. So, now, let us define constraints equation. So, here, makikita nyo dito, back then, makikita nyo dito na yung constraints equations natin is may XA, isang XA plus tatlong YB plus constant is equal to the total length. So, differentiate the constraint equation in relation to the velocity and acceleration. So, here, for the expressing this into acceleration and velocity, well, we can rewrite that VA plus 3 times our velocity B is equal to 0. And our acceleration will be AEA plus 3AB is equal to 0. So, which is actually we can actually denote as our equation 1. So, now we have to write the equation of the motion for block A and B. So, with the axis, so, di ba, the forces, the summation of forces of an X component is equal to MA, di ba, kasi dito, A lang naman, yung X component natin is A. Ito, so MA, AA, so acceleration A, then mass times A. So, ating component X. And also, our, which is, sa taas, meron din siya. Diba? As I've said kanina, may tension tayo na papunta doon. So, papunta man doon yung tension niya, papunta doon to the right yung tension niya, dito, to the right yung tension niya, so that is why negative siya. So, we have to negative T is equal to MAAE. Where from equation 1, we know that AE, or acceleration of our block A, is equal to negative 3AB. So, ito lang siya. Ni-transpose lang to siya dito to the right. So, that is why we get this equation here. So, now, we are going to substitute this negative 3AB to our equation. So, this equation 1. So, MA multiplied to this 1 will be getting this. Since parehas lang negative and negative, magka-cancelled out. So, T is equal to 3MA A, acceleration A of our block A. So, which we have now our equation 2. And for the summation of forces at x, not x but y component rather, is equal to MB AB. So, MB AB. So, which as for the summation of forces y, makukonsider natin pababa, di ba, positive yung MB and tsaka yung gravity natin, multiplied to our tatlong tension, 3T. So, na, di ba, kasi 2T, then may isa pang T, so kaya naging 3T siya. So, negative siya kasi pataas man yun. So, which is yung ating positive Y na axis system is pababa. So, that is negative. So, meron na tayong equation 3. So, now, simplifying equation 3, substituting the value of T in equation 2. So, this is our equation 3, right? And our equation 2. So, ilalagay natin to dito, o isa-substitute natin to dito sa my 3. So, we will be getting this MB multiplied to gravity minus 9, MA, or the mass of our block A multiplied to AB, is equal to the mass of our B multiplied to our acceleration B. So, we are going to simplify this one. So, simplifying this one, we can now have our MB multiplied to G over, then ilalabas natin tong acceleration B natin dito. So, meron tayong MB plus 9MA. So, cancelled out na yan siya. Cancelled. Then, yan. Magiging A is equal to MB G, gravity, multiplied to MB plus 9MA. Which we can also cancel out the MB here kasi may MB sa taas, may MB din sa baba. So, cancelled out siya. So, that is why we are left with our A, acceleration B is equal to the gravity multiplied to 1 plus 9 mass of our A and mass of our B. Since we are given with our masses, which is 30 kg for our A, and for the B naman din is 25 kg. So, the gravity now, we know that 9.81 meter per second squared. So, we are going to substitute that one, these values to our equation here. So, that gives us the acceleration B is equal to 0.831356 meter per second squared, or just equal to 8.31 times 10 to the negative 1 meter per second squared. So, now, to solve for T, so our equation 2T is equal to 3MA AB. We have this value of our mass, block A, 30 kg, and since nakuha na natin kanina yung ating acceleration ng ating body V, so, which is 0.83156 meter per second squared, so we are going to substitute that one to our equation. So, substituting that, we will be able to get the tension. So, now the tension will be equal to 74.82204 Newton, or just equal to 72.8 Newton. Since we are done calculating our acceleration B and the tension, we are left with the acceleration A. So, to calculate our acceleration A, since we are given with our acceleration B, we are going to substitute the value of the acceleration B that we get kanina. So, that is why, this is the equation 1, diba? So, we are going to substitute the value of AB, acceleration of our block B. So, we will be getting negative 2.494068 meter per second squared, or just equal to negative 2.49 meter per second squared, or just equal to 2.49 meter per second squared moving to the right. So, therefore, the acceleration of each block is 2.49 meter per second squared, or negative 2.49 meter per second squared, and for the block B, acceleration will be 8.31 times 10 to the negative 1 meter per second squared, while the tension in the cable will be equal to 74.8 Newton. So, normal and tangential coordinates. So, our here, normal and tangential. So, our tangential force will be, if we have the mass, consider the mass M dito, which is acted by the force A. Mass, so ito yung path ng ating particle. So, yung mayroon tayong tangential na coordinate, at saka meron din tayong normal coordinates, which is perpendicular to our tangential. So, So this is for the FBD. So considering this for the FBD one here, and for the, kasi FBD summation of forces dito, then dito naman din is we are actually expressing that into the mass times acceleration. So relating to the normal and tangential coordinates. So here we will be our tangential will be the MAT and the normal will be the MAN. So as I've said kanina, relating the second law with respect to the normal and tangential component will gives us this one. So for the summation of our force tangential to the path of our particle, so we have this MAT, which we can so we know that AT, or the acceleration, or which relating to the tangential coordinate, so is equal to dv over dt, which makikita nyo dito sa baba, it is now expressed into m is equal to dv over dt. While for the normal coordinates naman then, relating to this one, so the summation of our forces is equal to m an. So the summation of the forces relating to the normal coordinates is equal to m v square over the rho, or is just equal to r. So now, to be able to illustrate this normal and tangential coordinates, we are going to have our example 4. The 3 kg collar B rests on the frictionless arm AE from here to here. Yan siya. So the collar is held in place by the rope attached to the drum D. This is our drum, and rotates about O. Magro-rotate siya sa ating O in a horizontal plane. So the linear velocity of the collar B is increasing according to, it is given as V is equal to 0.2 t square, where V is in meter per second and that time is represented as seconds. So find the tension in the rope and the force of the bar on the collar after 5 seconds if the radius is equal to 0.4 meters. So the given, we have the mass of our collar B, 3 kg, and our velocity, which is in an equation form, which is 0.2 t square. So required is the tension and the tension and the force. The force of our after t is equal to 5 seconds if yung ating radius is equal to 0.4. So, solution. First thing we have to do is to draw an FBD or KD of the collar. So, remember the tangential and the normal coordinates. So, tangential direction is tangent of the path of the particle. That is why yung sinabi ko kanina. And the normal direction naman din is perpendicular to the tangential direction. Points towards the end side of the curve. So, consider yung ating figure 2.1, which is kanina. So, ito yung point O natin. So, if we can actually rewrite the tangential direction and normal direction. So, tangential kasi dito, di ba? If this is the path of our particle, so yung ating tangential directions will be that one, and yung ating normal direction will be this one. So, FBD, here we have this B, our B here, we isolated. The force acting on it will be the normal force and will be the tension. And for the kinetic diagram naman then, since we have defined the tangential and the normal coordinates of our system, well, meron tayong mass, AT, then mass multiplied to our normal acceleration with respect to the normal direction. So, now, let us express equation of motion in terms of tangential and normal components. Well, summation of forces sa normal component is equal to mass times An, where An, we can express that kanina, as I said, is equal to V square over rho. So, we can write this one here, this equation here, into N is equal to M V square over rho. And then, for the tangential component naman then, summation of Ft is equal to MAT, which AT is equal to dV over dt. So, T is equal to M dV over dt. So, solving for velocity, for the Vt, An, and At, so for Vt, we are given with V is equal to 0.Ta square. 0.2 t squared. So which we are given also with the time, 5 seconds. So we are going to substitute that 5 seconds into our V. So which gives us the Vt is equal to 5 meter per seconds. For the AN naman din, acceleration natin at normal component or normal direction. So, AN is equal to V square over the rho. Where V is equal to Vt, mayroon tayong 5 meter per second as calculated kanina. And also the rho or the radius of our particle will be 0.4 meter. So, AN 5 squared over 0.4 will be getting 62.2, not 2 but 62.5 meter per second squared. So for acceleration at tangential component naman din, AT is equal to dV over dt, where we know that V is equal to 0.2 t squared. So we have to derive that one. So it gives us dV over dt is equal to 0.4 t. So meron na tayong equation. AT is equal to 0.4 t. Since we are given with 5, again, 5 seconds, well, AT is equal to 0.4 times t, which is 5, which gives us the 2 meter per second squared. So now, we have to solve the force and the tension. From the equation above, we know that N is equals for the force is equal to MAN, where AN is equals to 62.5 meter per second squared and the AT is equal to 2 meters squared. And the mass of our body is equal to 3 kilogram. So substituting these values here, it gives us for the force or this force at normal directions, 3 kilogram multiplied to 62.5 will give us 187.5 Newton. Well, for the tension naman then, so T is equal to MAT, so 3 kg multiplied to 2 meter per second, which gives us Newton. 2 Newton. Actually, kulang to ng squared. Sorry for that, pero may square 2 dito, so that is why it gives us 6.0 Newton. Therefore, the tension of the rope is 6 Newton and the force of the bar of the collar, diba collar yung B, is 187.5 after 5 seconds when the radius is equal to 0.4 meters. And now, we're going to talk about the last part, so the energy and momentum methods. Methods in this part, we are introduced into method of analysis. First is the method of work and energy, which is it directly relates to the force, mass, velocity, and the displacement. While the method of impulse and momentum is directly relates to the force, mass, velocity, and the time. So, as previous chapter, we discussed about Newton's second law, which is the submission of forces is equal to mass times acceleration. Which for the velocities and displacement, so regarding to work and energy, so we can denote as T1 plus U movement from 1 to 2 is equal to the T2. So velocities and time, so for the impulse and momentum, mass times velocity 1 plus the force dt, which is actually evaluated from time 1 to time 2 is equal to mass times velocity, second velocity. So, work of the force. So, work of the force, so work is considered as a scalar quantity. It has a magnitude and sign but no direction. So, the units of work is 1 joule or equal to Newton meter. So here we have the differential vector of our particle, the dr, here 1. So this, we relate that into work. So this is the work is equal to the force multiplied to the differential vector. So which we actually note also that into F ds cos alpha, cos of our alpha here, then or to the component of our forces, the rectangular component, which is equal to fx dx plus fy dy plus fz dz. So, during the finite displacement here, the work is represented by the area under the curve as shown as plotted in this figure. So, the ft against the ds. So this one here, s is the length, diba? So this one here is the work. This represents the work. So the work of force, as the motion from 1 here, position 1 to position 2, diba? From position 1 to position 2 is equal to the force multiplied to our position vector. Our position vector. So that is our, not position vector, but the differential vector here. The differential vector. So which actually evaluated from our first, for area 1 down to area 2. So expressing this one also into f cos alpha, kanina cos alpha ds, the change of our s, then evaluated from s1 to s2, or the ft, or equal to ft, which is the force in the direction of the displacement ds, multiplied to ds evaluated to s1 to s2. So also for the rectangular component, or considering the component of our forces, the y, x, and z, so fx dx plus fy dy plus fz dz evaluated from our first a down to a2, or the position 1 down to 2. So principle of work and energy, considering our mass m here, which is acted by the forces here. So Ft, we know that we can get a tangential force here, diba? Tangential force. So which is mass times tangential component na acceleration, which we can also denote as m is equal to dv over dt. So this one here, we can also express this dv over dt is equal to dv over ds over dt, which we can say that this ds over dt, diba, the change of the length of the change of the direction of our particle over the change of the time is just the velocity, diba? So we can write that v is equal to ds over dt. So meron na tayong v dito, and also we are left with dv over ds. So relating that the change of s, or the change of the distance, and the change of the velocity, so ft is times ds is equal to mv dv. So integrating that, since we have this position here from first this a1 down to a2, so also our distance will also change, diba? So ft ds evaluated from s1 to s2 is equal to mv dv evaluated from v1 to v2, which is equal also to 1/2 mv2 square minus 1/2 m1 to the raise of 2. So which the kinetic energy, which the work will be equal to t2 minus t1, as our movement is from 1 to 2. So where t is equal to 1/2 mv squared, so which t is the kinetic energy. So the work of the force F here is equal to the change in kinetic energy of the particle. Actually, the work and kinetic energy, and the work or the energy and work and the potential energy have the same unit lang. So to be able to understand it more, we are going to discuss example 5. So a section of track, this is a track for a roller coaster, consists of two circular arcs, which is from AB and BC, joined by a straight point here, which is BC. AB and CD pala. So the radius of CD is equal to 240 feet. The car and its occupant of total weight is 560 pounds. So reach point A with practically no velocity, so and then drops freely along the track. So determine the normal force exerted by the track on the car at point D dito. So neglect air resistance and rolling resistance. So given we have, as stated on the problem, we have the velocity 0 feet per seconds at initially. So wala talaga. So and our radius from C to D, so we have this 240 feet. And weight of our occupants and the track is 560 pounds. So required is the normal force acted of to the body, so at point D. So solution, so for the FBD, we draw this one. We know that 240 rather yung kanyang ng kanyang radius from point C to point D. So and the force is acted on the body that we are isolated or that we are considering is actually normal force at point D, so which is ND, upward, pointing upward, and the weight is pointing downward. So now KD, so for the kinetic diagram naman din, as we know that yung tangential direction and normal direction. So as we defined those directions, EN and ET, so we will now have our MAN and our MAT. So using Newton's second law in the normal directions, we will be able to get this as working equation. So the summation of the force at normal direction is equal to the mass times the acceleration, AN. So which this AN, we know that VD square over R. So we substitute that value in this one. So and now for the summation of forces, what are the forces that acts on our track and the occupant? So here meron tayong normal force and our weight. So ND minus weight is equal to mass. So here our working equation, ND is equal to mass times VD square over R plus the work. So for the working equation that we have, we can find or draw equations for VD using conservation energy. So by conservation energy from point A and D, so we can write that TA plus VA is equal to TD plus VD. So for position A, atong datum ani is ang VA, this one, VA. So this VA is equal to 0. And in this part, our TA or our kinetic energy at point A is equal to mass over acceleration. Not acceleration, but 1/2 mass times velocity of at point A square. So we have 0 here. So we also consider that TA at datum VA is equal to 0. So TA is equal to 0. At point D, so when YD is equal to 0, VD is equal to 0. So conservation of energy equation will be simplified. So masisimplify na natin siya. Dalawang 0 man, yan. This is actually velocity ha. So dalawang 0, yung TA tsaka yung VD. So kaya't matatawag na yung VA is equal to our kinetic energy at point D. So where VA is weight multiplied to the direction A. So which weight is equal to 560 pounds. So let Y, ilalet natin yung Y is the total of Y traveled. Galing sa point A down to point D ng ating system. So Y is equal to 90 feet plus 60 feet. Bakit Y is equal to 90 feet plus 60 feet? Well, going back to our illustration here, 'di ba? Kasi sinabi na from A to D kasi. So 'di ba, we have the arc. So we know that at AY, so this is actually potential energy na part in which this one here, the length here is equal to 90 feet, then plus CD, YCD is equal to 60 feet. So i-add natin yan. So now, so that is why we will be able to get the 150 feet. So multiplying this 150 feet to our VA, we will be able to get this 84,000 pound per feet. So VA, so meron na tayong VA. So now to calculate the TD, so we know that TD is equal to 1/2 m VD square. So we have this a value of m. M is just equal to weight divided by the gravity, di ba? 560 pound divided by the 32.2. That is divided by the 32.2 or 32.1740 feet per seconds. So that is why we will be able to get the mass 17.4054 pound. Now, multiplying since wala pa din tayong value ng ating D, so we can equate this one, the TD and the VA, since, di ba, as kanina, yung TA is equal to 0 and VD is equal, and VD equal to 0, so we have VA is equal to TD. So now, equate natin siya, meron tayong 84,000 pound-feet is equal to this one. 8.7027 VD square. Where makukuha na natin yung ating velocity at point D. So, velocity of our point D will be equal to 98.245 feet per seconds. So, by equation 1, di ba, our work equation is this one, the equation 1, and D is equal to M VD square over R plus W, or the weight. So, since we already calculated the VD and we have the value of the weight and the mass, and also we have the radius, we will be able to solve or to calculate the normal force acted at point D. So, the W is equal to 560. So, this is the 560. The mass is equal to 17.4054 multiplied to our 98.245 feet per seconds to the square over 240 feet. So, it will gives us 1,259.99 pounds or 1,260 pounds. So therefore, the normal force existing by the track on the car at point D is equal to ND 1,260 pounds. Potential energy. So potential energy is considered as the latent energy of an object at rest. So here, instead of following, diba, we are actually calculating this kung saan papunta yung ating body na kino-consider, yung ating particle. So, kung saan yung path niya. Here, it's not the case. So, W with an arrow is the work force of the gravity. So, now, it is independent of the path followed. So, it only depends on the initial and the final values of our weight with respect to the y-axis. So, Vg is equal to Wy. So, potential energy, this is the potential energy of the body with respect to the force of the gravity. So, our work will be equal to from 1. So, this is the motion, the movement of this is A1 down to 2. So, which is equal to Vg1 minus Vg2. And also work of the spring exerted by the spring, or the work of force exerted by the spring, depends only on the initial and final deflection of the spring. So which we denote that U from 1 to 2, that's the movement. So is equal to 1/2 key x1 squared minus 1/2 key the position 2 to the power of 2. The potential energy of the body with respect to the elastic force is equal to VA is equal to 1/2 kx squared. So, which we can also rewrite this upper one, this work equation here into with respect or relative to the potential energy into U from 1 to 2, so is equal to movement 1 to 2 is equal to VE1 minus VE2. So, it is illustrated here, the potential energy of the body with respect to the elastic force. So now, let us have our example 6. A 2 kilogram block A is pushed up against a spring compressing it a distance of 0.1 meter. The block is then released from the rest and slides down 20-degree incline until it strikes a 1 kilogram, until it strikes daw at 1 kilogram na ball or the spear, which is suspended from 1 meter and extensible rope. So, the spring constant, the K here, is equal to 800 Newton per meter. The coefficient of our friction between A and the ground, here is 0.2. So, the distance A slides from the unstretched length of the spring is the D. This is the D1 is 1.5 meter. And the coefficient of restitution between A and B is 0.8. When alpha is equal to 40 degree. Here, alpha is equal to 40 degree. Find, una, ano yung speed ng ating B? What is the speed of the B? And second, will be the tension in the rope. So we are given with ang MA natin is 2 kg, ang MB natin or mass of the ball or the sphere is 1 kg, and the the K is equal to 800 Newton per meter. Then we have the 0.2, the restitution 0.8 x 0.1, and the distance 1.5, the L and stretch is 1.1 meter. So alpha 40 and the theta will be 20 degree. So required the VB and the tension of our root. So solution. Use work energy to find the velocity of the block just before the impact. So bago pa ang impact. So we are considering this isolated body, ating block A. So block A, meron tayong frictional force here. And also our spring, the force of our spring exerted by our spring, the weight, and the normal force, and the theta. So for the KD naman din, or the kinetic diagram, we have this MA. So now, summation of the forces in Y direction. So Y direction natin. So Y direction is. So summation of forces Y direction is equal to 0. So now, the forces here, meron tayong in Y direction dito. So meron tayong normal force and meron din tayong weight. So which actually normal force N minus the weight of our block A cos theta is equal to 0, which we are given with 19.62. That 19.62, we calculated that one. So this 19.62 is just equal to the mass A times the gravity. 2 kilogram times 9.81 meter per second squared will be having this 19.62 Newton. So alpha is equal to 20 degree. So we have 18.437 Newton. So now our N, the normal force, is 437 Newton. Now, for the frictional force can be solved using this frictional force is equal to mu K times the normal force. So, since mu K here at point A here, at block A is meron tayong given na 0.2. So, the spring coefficient man to siya. So, frictional force is equal to mu A, then the normal force which we calculated kanina. So now, our frictional force will be equal to 3.6874 Newton. Moving forward, so we have to use work and energy to determine the VA at impact. So we have to set our datum. So here, this is our datum here. So we have the distance and the x here. So T1 plus V1E plus V1G is, plus the work of force is equal to T2 plus V2E plus V2G. So now, we have to solve the values for each term. So for T1, so this is 0. So V1E naman din is just equal to 1/2 kx1 square. So we are given with a K, 800 Newton per meter, and we have this x, 0.1 to the square, so which V1E gives will be equal to 4.0 or 4 Newton meter, or just equal to 4 joule. So for the V1G naman din is just equal to the mass A multiplied to the gravity times the height. So the mass A natin is equal to 2 kg. Then our gravity will be 9.81 meter per seconds. Yung height natin is just the x, or the addition of x and the distance, which sine alpha, or not sine alpha but sine theta. So this one, 0.1 plus 1.5 sine theta is then it will be equal to 1.6 meter sine theta. Then theta is equal to 20 degree, diba, as given. So we can now calculate the V1G is equal to 10.7367 joule. So work of force, moving from 1 to 2. So position 1 to 2 is equal to negative frictional force multiplied to the x and the d. So, multiplied to the x and the d. So, is equal to plus d pala. So, as calculated kanina, we have the frictional force. We calculated that one, which is negative 3.6874 Newton. And our x plus d is just equal to 0.1 plus 1.5. So that is equal to 1.6. So negative, multiplying this one gives us the work of force is equal to negative 5.89984 Newton meter, or it's just equal to negative 5.89984 joule. So for at point 2 naman din, at point 2, diba? At point 2, T2 is equal to 1/2 MAVA square. Dito, wala tayong value ng ating VA. So, which is we are going to calculate that one. So, we have this 2 kg, 1/2 times 2 kg VA square. So, we have T2 is equal to 1 VA square. So, then the other term that we are going to solve is the V2. The V2. So, V2 in this part is equal to 0. So, now, we have to substitute the calculated values to work energy equation to solve VA. So, since wala mang VA, so, 0 man yung T1, 0 din yung T2. So, meron tayong mga values ng V1E and V1G plus the work of force. So, here we are going to substitute those values that we get. Okay? So, now, for joule plus 10.7367 joule plus negative 5.8994 joule is equal to 1 VA square. So, divided by 1, so we have this VA square is equal to, we are left with 8.8373 square meters per second square. So, now, square root of that one will be our VA, or the velocity at point A. So VA is equal to 2.973 meter per seconds. So now we are going to use conservation of momentum to determine the speed of the ball after impact. Gaano nga ba kabilis? So this is the conservation of the momentum. MA plus VA is equals to SP dt is equal to this one here. So this is the position that the data here, then MA VA with an apostrophe. So that changed to siya. So that change mo to siya after the change, 'di ba? After the change or after the impact. So sa both bodies that you can see in this screen is kailangan nating i-consider, di ba? Meron tayong dalawang body, the block A and the sphere. So for the sphere naman din, so we have this ST dt and also the SP dt will be equal to the after the impact, which is the MB VB or VB with an apostrophe. So at x direction, kung i-apply natin yung conservation of momentum, we have this MAVA cos theta plus 0 is equal to our MAVA with apostrophe cos theta plus MBVB. Okay? So, here, since 0 na siya, so 2 times cos 20 degree multiply to our VA which is 2.973 is equal to 2 cos 2 degree VA with an apostrophe plus 1 kilogram VB. So we have this equation na 5.5874 is equal to 1.8794 VA with an apostrophe plus 1 VB. Now, to consider the relative velocities or the coefficient of restitutions, we know and it is discussed in previously that sa ating klase sa video na sinend sir, that this is the formation of our coefficient of restitution. So V with an apostrophe N minus VA apostrophe N is equal to E VAN minus VBN. Since 0 tong ating VB dito, so we are left with E dot VAN. So since VA is equal to 2.973, so we are going to at least substitute that, as well as we have the restitution coefficient, which is 0.8, which we are getting this VB with an apostrophe cos theta minus VA. This apostrophe is equal to 2.3784. So solving this one, nakita nyo kanina meron tayong equation equation A and equation B. So actually you can either use directly solving simultaneously your calculator. Makikita nyo dito yung calculator. Then you are going to choose the equation apart, which gives us the AY plus AX plus BY is equal to C, or yung ganun na equations doon sa ating calculator. So solving simultaneously, we are going to place the two equations A and B here na nakatungod siya, VB when VB is then VB apostrophe. So 1.0 VB plus 1.8794 VA apostrophe is equal to 5.5874, which is our equation A, and our equation B is equal to cos 20 degree VB apostrophe minus VA apostrophe is equal to 2.3784. So, solving simultaneously, we will be able to get this VB and VA. So, where VB is equal to 3.63599 meter per second, and for the VA is equal to 1.03831 meter per second. So, now, use work and energy to find the velocities at alpha. So, we can determine here, di ba, motion niya, di ba, at point 1 ito, wala pa. This is the datum. At point 2, dito siya. So, we can determine VB at alpha since given naman tayo 40 degree using work energy conservation. So, T1 plus V1E plus V1G plus the work of force is equal to the kinetic at point 2, then V2E and V2G. So, T1 is equal to 1/2 mb VB squared, where V1 here is equal to 0. 1/2 multiplied to 1 kilogram, then 3.63599 squared is equal to 6.6102. So, which is our kinetic energy at point 1. Then, ano yung ating point, sa ating point 2? T2 is equal to 1/2 mb V2 squared. Well, V2 is just equal to mb gravity times the height, which is the height natin is 1 times 1, this is not 1, but this is actually L. So, 1 minus cos alpha. 1 kilogram multiplied to 9.81 meter per second, then multiplied to height, which is, ating pangalawang height, which is L, 1 minus cos 40 degree. Well, L is equal to 1 meter. So, V2 natin is 2.2951. So, substituting the values to work energy equation. So since V1 natin as stated kanina is 0, so we have 6.6102 plus 0 is equal to 1/2 itong V2 square. Then plus 2.2951. So, simplifying this one, since ito na lang yung natitirang variable natin, so we are equating other values to the other side. So, 6.6102 minus 2.2951 over 1/2 times 1 will gives us 8.6302 meters square per second square. So, the square root of that one will give us the velocity at point 2, which is 2.9377 meter per second. So that is the speed of our sphere at point B. So now, find the tension in the rope. We can solve using Newton's second law of motion. So we go back to the Newton's second law of motion, the FBD of the ball. So here, we have the acting forces on it. So we have this weight of the ball or the sphere. WB is equal to mass times gravity. So we have this alpha here. And the tension. So key D, so the kinetic diagram, we defined En and Et. So MBAN and MBAT. So that is. Then apply summation of forces in the normal direction. So for the normal direction, summation of forces is equal to MBAN. So where AN is equal to V2 square over rho, which rho is equal to R is equal to 1 meter and the V2 is equal to 2.9377 meter per second. Kasi yung V2 is the velocity of our ball of our sphere at point 2, which we calculated kanina. So AN is equal to 8.6301 meter per second squared. So now TB minus WB cos alpha is equal to MBAN. Actually, okay, this is actually forces, summation of forces normal direction. So meron tayong T minus WB cos 40. So MB is 1 kilogram, WB is mass of our sphere times the gravity, which is 9.81, which this is just equal to 9.81 Newton. Then at alpha is equal to 40 degrees. So T minus 9.81 Newton cos 40 degrees is equal to 1 kilogram times 8.6301 meter per second squared. Then this will actually gives us that T, the tension here of our rope, is equal to 8.6301 Newton plus, so ipunta siya dito sa kabila, transpose. So maging 8.6301 Newton plus 75149 Newton. So the T rope is equal to, or the tension of our rope in this problem is equal to 16.145 Newton. Therefore, the speed of our sphere is equal to 2.9377 meter per second. So this is after the impact. So and the tension of the rope is equal to 16.145 Newton. So this is our textbook, Vector Mechanics for Engineers, 10th edition, by Beer, Johnston, Mazurek, and Cornwell. So this is the link. Thank you and God bless. Again, I am Rudin Bautista, BS Chemical Engineering student.